Hello, Internet. So I thought today I'd talk about how to create your own WebAssembly files, just to completely demystify the file format. So last time in talking about my C compiler that fits in one file, I described what WebAssembly is. So basically, if you kind of imagine how the program pipeline works, right? You have source code that gets compiled to an executable, and the executable needs to target an architecture like x86 or ARM together with the operating system that helps you, do stuff out in the real world. And if either of these don't match, your program can't run. WebAssembly is a similar structure. You have some set of source files, you compile it down to WebAssembly, and then that WebAssembly runs on an architecture, in this case WebAssembly, and an operating system, which essentially is the browser, right? Anyway, so with this in mind, what is actually in this Wasm file, right? This is from the official WebAssembly spec, which is actually quite readable. I'd encourage you to read that. But there is actually a lot of stuff. If you're targeting a specific language, there are actually a lot of sections that you might not need. And it still is a technical document, so it might not be as easy to walk through it yourself. At the highest level, it really is quite simple. You just have a magic end version, like these 8 bytes up here. Every WebAssembly file starts with these 8 bytes, and then sections that follow, right? And then each section has a section ID, the size of the section itself, like how big the content is, and then the content itself, which depends on what kind of section you're emitting, right? Like whether it's code, if it's a code section, it'll have the actual opcodes in here. So to start with, we can keep things quite simple by just having an array that contains an array of bytes, and then we'll just shove that into a UN8 array to get our buffer, right? This way, we basically have a binary format. We're literally putting in 1 byte at a time into an array to generate our file. And we start first section. The first part is quite easy. We just put in the same 8 numbers, 8 bytes that we expect to see. And then for each section, we need to emit the section ID. And the section ID determines what kind of section you're looking at, right? And then the contents, right? Okay, so we have this helper section function here. And the section helper function just looks like this. Basically, an ID is always 1 byte. And then we have the length, but because the length can be over a byte, we do need some sort of encoding to determine how we're gonna, specify the length of the content, and then the content itself, right? So to really get into it, I think it's worthwhile, first fleshing out a few helpers in this file format that we're going to see again and again and again. Fundamentally, there are 3 things that come up again and again that are quite useful to have. Integers, signed and unsigned. It is kind of the most natural way you would expect to encode integers in a variable of bytes, right? And if you've seen UTF-8, right, like how UTF-8 encoding works is quite similar. So the basic idea is this. You have 1 or more bytes, and each of the bytes contains a bit that tells you if it's the last byte or not. That's basically the idea, right? So here's an example, it's quite common that you're going to need 32 bits. If the rest of the bits are going to be 0 for an unsigned type, you can actually omit some of these other ones and just set 0 up here, right? There are variants. If the number is small enough, it actually doesn't matter, whether or not you want U32, U64. If the number would fit in U32, the encoding actually for U64 version is exactly the same. The encoding itself does not have a fixed size, right? So in code, this is kind of what it looks like. As you can see, there's no artificial limit on how big the number has to be. But in practice, the decoder, when you try to run WebAssembly files, when something should be a smaller size, will actually throw an error saying the number you gave me is too big. And then the signed version is a little bit more. It's a little bit more code, just a little bit more code, because you have to also take into account sign extension. Make sure you do that properly. But yeah, and so the integers are kind of the slightly more involved ones. Strings and lists are actually quite a bit simpler. For strings, you just take the UTF-8 encoding, attach the length of the string in front of it. Vector of items, conceptually a list of items, right? It works the same way. A number in the beginning of the vector telling you how many items are in it, and then you literally just push the items inside, right? So with those helpers in hand, we can actually get into the section. So The actual single file C compiler, compiler.js, emits these set of sections, but a lot of these are actually these aren't necessary for certain, but I think to get started, just seven sections are actually it's enough for it'll kind of give you an idea of how to add the other sections as well when you need them, right? At a very high level, these sections also, they just encode kind of the things you would expect to need when you're trying to run, when you want to run a program, right? So the type section actually will encode other types when you say have GC structs and arrays, but when you're compiling C, you actually don't need that because all of your complex data structures, they live in linear memory, right? The only thing you still do need are function signatures. They do need to live in the type section. You have the import section, which lists the things that the host must provide for this WebAssembly module to run. And then you have a list of functions that are defined inside this WebAssembly file. For memory, this is usually a very short section that just says, I need some linear memory that I can read and write. And then you specify roughly what is the amount of memory that this module needs, what is the maximum amount expected. You have the export section where you can export global variables, memory, functions, other assets defined inside this module so that it can be used by the host system. So at a minimum, in order to run with my host, you need to export the main function so that the host can run the main function to start the program. The code section is a fun one. This is the one where you have all the bytecode instructions, all the local variables that are used, and then the data section, if you have static bytes that you want to embed into the thing. The data section lets you just put in the bytes and say, I want these bytes available in linear memory at this offset when the program starts. Yeah, so that's kind of the high-level view. Looking at the actual code of how it's done, right, you have for each function, like in this case, in our demo, we really only have two functions that we need to use, the write function and the main function. The write function has 3 integer arguments it accepts: the file descriptor, the pointer to the data you want to print, and then the length of the data, and then it returns a single integer. The main function has no arguments, and it returns a single integer value. And then you just return those two things, right? You just encode those two things. For the import section, you need to specify the module and name. These are pretty arbitrary, but you do need to specify the module and name that the host must provide. You just need to declare that it's there. And then you can import other stuff. You say that I want to import a function, not like, say, a global variable or something. And then the sections, function section, memory section, export sections, these are also quite short. The function section, literally, this is just a list of types for each of the functions that you declare in this WebAssembly module. So, like, the main function corresponds to the type that we defined earlier, right? So you don't actually specify the types here. The function signature is already defined in the type section, and then you just refer to them from here. You have the memory section where you just say, essentially, you just tell the system, I want some memory. And you say, I want at least 64 kilobytes. It's one page. You can't request less. I mean, it's always in multiples of 64K. And then you also have an export section where you export the memory so that the host can also look into the memory if it needs to. And then you have a main section so that the main function is available to the host so they can be run. And then the code section. So this could probably be its own video, but WebAssembly is a stack machine. You put the arguments on the stack, you call it. When you call, you specify the index, the ID of the function that you want to call, right? And then you package that into together with what local variables are used, and that's it basically. And then the data section, we have the hello world string that we want to print encoded in UTF-8, and then we just use them here. We just put that in here. You specify the offset. In this case, just as a demonstration, we put the string at position 14, and then we put the string data at position 14, memory address 14 inside linear memory. And then that's it, actually. That's all you need. Like, no other magic, really. And then, you just write it into file. Like, as a demonstration, I just created the hello.wasm with that script, and then you can just run it and see that it works. And then, you can also use a disassembler from the other video. So here is the example disassembler, and you'll see here, if you created the hello, you can just dump it in here. And then, you see all the sections available. You see the data section, memories, exports, imports. You can even run it, right? So the debugger, you can see debug, data, and output. And then you can step over one instruction at a time, and boom, right? You see the thing.